Welcome. If you've ever wanted to understand how software actually works, not frameworks, not abstractions, you're in the right place. C++ is where that journey starts. In this presentation, we'll cover three things: getting a working compiler, writing and running your first program, and building a mental model for what happens when you compile code. C++ has a reputation for being intimidating, but the barrier to entry is lower than you think. You need a compiler, a text editor, and about 12 minutes. Let's begin. A compiler is the program that translates your C++ source code into something the computer can actually execute. There are three compilers you'll encounter. GCC, the default on Linux, also available on macOS. Open source, battle-tested, excellent error messages. Clang, preferred on macOS, comes with Xcode command line tools. Excellent diagnostics and strong cross-platform support. And MSVC, Microsoft's compiler for Windows, tightly integrated with Visual Studio. All three produce standards-compliant C++ 23 binaries. The code you write today works on all three. The only difference is installation path and command line syntax. Every C++ program starts with a file. Just text, nothing more. Here's the simplest program that actually does something. Include IO stream. That tells the preprocessor to pull in the standard IO library. Without it, cout doesn't exist. Int main, the entry point of every C++ program. Execution always begins here. Then stdcout, shift left, quote, hello C++, that writes text to standard output. The std prefix is the namespace, and cout is the output stream. Save this file as main.cpp. The .cpp extension tells the compiler this is a C++ source file. Compilation is the act of translating human-readable source code into machine instructions. For GCC or Clang, the command is g++-std equals C++ 23 capital W all capital W extra pedantic main.cpp -o app. The std flag enables the C++ 23 standard. Wall and W extra enable all warnings, critical for learning because the compiler will catch your mistakes. Pedantic enforces strict standard compliance. For MSVC on Windows, the command is cl/std:/C++23/W4 main.cpp. W4 is MSVC's equivalent of wall and W extra. If compilation succeeded, you now have an executable file called app. On Linux or macOS, run it with /app. The / means in the current directory. On Windows, just type app.exe. The output, hello C++, success. Now here's the important part, the edit, compile, run loop. This is the fundamental development cycle. Step 1, edit your source code. Step 2, compile. Step 3, read warnings. Never skip this step. Step 4, run the program. Step 5, repeat. Every professional developer follows this loop thousands of times per project. Learning to read compiler warnings early is what separates good developers from frustrated ones. When you run a compiler command, three separate things happen in sequence. Understanding these stages will save you hours of debugging later. First, pre-processing. This expands include directives, processes define macros, and strips comments. It produces what's called a translation unit. Second, compilation. This translates the pre-processed C++ into architecture-specific machine code, producing object files. Third, linking. This combines multiple object files and resolves symbols. For example, it connects stdcout to the standard library implementation. The output is your final executable. Most beginner errors occur at one of these three boundaries. Missing includes at the pre-processing stage, syntax or type errors at the compilation stage, or undefined symbol errors at the linking stage. There are two build modes every project should use from day one: debug and release. The debug build adds the -G flag, which embeds debug symbols, so tools like GDB or LLDB can show you source line information when something crashes. It also uses -0, zero optimization, keeping the code structure close to what you wrote so debuggers work predictably. The release build uses -02, level 2 optimization. The compiler reorders, inlines, and restructures your code for maximum performance. No debug symbols, smaller binary, faster execution. Establishing this two-build habit early prevents a common mistake: shipping debug builds or trying to debug over-optimized code. Real programs read input, process it, and produce output. This program does all three and introduces four foundational concepts in one pass. First, we include string. That brings in stdstring, C++'s safe string type. Then, we declare a variable, stdstring name. Next, we prompt the user with cout. Then, stdgetLine reads a full line of input, including spaces, into the cum, into the gout. Then, stdgetLine with stdstring name. Next, we prompt the isSeat. Finally, we output a personalized greeting. Notice we use get. The extraction operator stops at whitespace, which would truncate a name like Jane Smith to just Jane. GetLine is the correct tool for reading full-line input. Putting everything in one file works for toy programs. As soon as you have more than one concept, you need structure. Here's a layout that scales. At the top level, your project directory. Inside it, 3 folders. src, where all your .cpp source files live. This is what you write and edit. Include, where header files live. These are declarations shared across source files. And build, where compiled artifacts go. Object files, executables, everything generated. The key rule: never version control the build directory. Add it to your git ignore. Keep generated files out of your source directories. When you later adopt build systems like CMake or Meson, this structure maps naturally to how those tools expect projects to be organized. In real C++ projects, you don't put all your code in one file. You split declarations from definitions. Here's the pattern. The header file, math.h, contains only the declaration int add, int a, int b, semicolon. That semicolon means this is a declaration, a promise that this function exists. Any file that includes math.h knows about add without seeing how it works. The implementation file, math.cpp, contains the definition, the actual function body that returns a +b. This gets compiled separately into its own object file. Then, main.cpp includes math.h and calls add. It compiles to its own object file too. The linker combines both object files into the final executable. This is the foundation of every large C++ codebase. Thousands of files, each compiled independently and linked together. The compiler will stop you. That's its job. Here are the 4 errors you'll see most in your first week. Number 1. Forgetting a semicolon. C++ statements end with semicolons. Every one. Number 2. Using a variable before declaring it. Variables must be declared before use. Scope matters. Number 3. Missing an include for a standard library type. If you use std string, you must include the string header. If you use std vector, include vector. Number 4. Compiling one file but forgetting to link another. If add is defined in math.cpp, you must compile and pass math.cpp to the linker. Here's the most important tip. Read the first error carefully. Later messages often cascade from the first one. One missing semicolon can produce 20 compiler errors. Always fix the first error, recompile, and reread.
You've written a program,
Compiled it, run it, and you understand how the build pipeline works. Here's what to add to your toolkit next. First, 4 standard library types you should learn immediately. std string for text, std vector for dynamic collections, std optional for maybe a value results, and std span for non-owning views into contiguous data. These 4 cover the vocabulary of modern C++. Second, bookmark cppreference.com. It's the authoritative, free, community-maintained reference for every standard library type and function. Third, set up your editor. VS Code with the C++ extension is the free cross-platform recommendation. Visual Studio Community for Windows, C Lion for a premium experience. Set up your editor tonight. Write one program, break it, fix it. That's the entire process. Thank you